A 230 kilogram piano is pushed to the right across the floor with a force of 60 newtons. The coefficient of static friction, the amount of static friction, is 0.12, and the coefficient of kinetic friction, the amount of kinetic friction, is 0.06. Draw a free body diagram, find the weight, find the normal force, find the maximum force of static friction, and the kinetic friction. So I'm going to start with that free body diagram. I have my box. There's a weight pulling the piano down. If the piano is pushing on the floor with its weight, then the floor is pushing back up with a normal force. This piano is being pushed to the right, so there is an applied force to the right, and that must mean that there is friction in the opposite direction to the left. So my free body diagram is done. Now I want to find the weight of the piano. Weight equals mass times gravity. The mass of the piano is 230 kilograms. Gravity is always 9.8 meters per second on Earth. Weight equals 230 kilograms times 9.8 meters per second squared. The weight of the piano is 2,254 newtons. I know that it's newtons because I have kilograms, I have meters per second squared, and we know that kilograms times meters per second squared equals newtons. So this is the weight of the piano. Now, what is the normal force of the piano? Well, the normal force is always equal to the weight. So normal force equals weight. So that means that my normal force also equals 2,254 newtons. All right, what is the maximum force of static friction? The equation for maximum force of static friction is Fs max equals the coefficient of static friction, so the amount of static friction, times the normal force. So the normal force right here, we know that normal force equals weight. So what we can do is we can substitute W in for Fn, the normal force in that equation. And so I'm going to do just that. So the maximum amount of static friction equals the amount of static friction times the weight. Well, now I also know that weight equals the mass times gravity. So once again, I'm going to substitute mass times gravity in for weight. My equation is now the maximum amount of static friction equals the amount of static friction times the mass times the gravity. And we know that our mass is 230 kilograms. Gravity on Earth is 9.8 meters per second squared. And they gave us the amount of static friction. So that mu symbol is the coefficient of static friction, which they told us is 0.12. So I have everything that I need now to find the maximum amount of static friction. So it equals 0.12 times 230 kilograms times 9.8 meters per second squared. So my maximum amount of static friction equals 270 newtons. We know that it's newtons because it's kilograms times meters per second squared, and we know that newtons equals kilograms times meters per second squared. So we have found the maximum amount of static friction, the maximum force of static friction is 270 newtons. So if you want to move this piano, you have to apply a force of 270 newtons. This person is only applying 60 newtons, so that piano is actually not being pushed across the floor. He's trying to push it, but it isn't moving. So lastly, we need to find the kinetic friction. So this should say, what is the force of kinetic friction? So that's what we're going to find. The force of kinetic friction equals the coefficient of kinetic friction, the amount of kinetic friction, times the normal force. And just like the last equation, we know that the normal force equals weight. Weight equals mass times gravity. So I'm going to substitute mass times gravity in for the normal force. So the force of kinetic friction equals the coefficient of kinetic friction, which we have here given to us as 0.06. The mass of the piano is 230 kilograms. Gravity on Earth is always 9.8 meters per second squared. So now I just have to fill in to this force of kinetic friction equation. 0.06 times 230 kilograms times 9.8 meters per second squared. So the force of kinetic friction is 135 newtons. Because we had kilograms, we had meters per second squared multiplied by each other equals newtons, because a newton equals kilograms times meters per second squared. So that is my last answer. And also notice that the maximum force of static friction was much larger than this force of kinetic friction. This 135 newtons is the amount of force that you would have to keep applying to push the piano. And the problem is done.